Good morning. It's Saturday, July 2nd, 2022. It's John Gilkison here, Aero Stealth, and I wanted to shoot a video this morning on how I calculate the energy efficiency for my Chevrolet Bolt EV in miles per gallon. I've ran across some arguments about how to do this a couple ways on Facebook, and to my mind I think some people fundamentally misunderstand the difference between the internal efficiency of the car and the total system energy it takes, which includes charging the car, and which has to be included in your mpg-e figure. And another thing is I also get the argument from some people that we shouldn't bother to calculate mpg-e. They just use miles per kilowatt hour or watt hours per mile. And I think this begs a question, because fundamentally when you drive your electric vehicle around, you're going to notice, you can't help but noticing, that about 95 to 97% of all the vehicles around you are still gas-powered cars. And there's quite an information gap out there on just how efficient electric cars are. I doubt very many petrol heads really understand that an electric vehicle is typically getting over 100 miles per gallon compared to their gas car. And quite frankly, with gas prices up around $5 a gallon, this is becoming more important. So anyway, now in my, it's going to vary from vehicle to vehicle, but in my Chevrolet Bolt, it's a 2019 model with a new battery pack, but it has a center stack which usually reads out and it says right here, and I'll show you at the top here, it says energy used, which in this case was 47.2 kilowatt hours, and then it tells me the distance traveled, 216 miles. This is the internal efficiency of the vehicle. Now, just when you calculate MPGs for a gas vehicle, you go to a gas station and you pump the gas in, and that gas replaces the gas you've just burned on a fuel cycle, and that's how you calculate MPG for your gas vehicle. Well, it's just the same with an electric vehicle. You have to plug it in after you had a cycle, and you charge the car back up to the same level, state of charge, that the battery was before. In other words, in my case, it's 90%. I charge to 90%, so I charge back to 90%, and then I get the number off the EVSE. And if you don't have an EVSE, that'll give you that amount of energy that it took to charge that battery back up to the same state of charge. You do have a problem, but there is a way around it, but it's not helpful not to have that report. So anyway, if I don't have that EVSE number, and there are reasons that I might not get it. For example, I might be charging my car, and in the middle of my charging cycle, the electric company will decide to go offline for, doesn't matter, few seconds or few hours. It clears the counter on my EVSE. It zeroes it out. So I may lose that data. So in that case, I use 90% as a charging efficiency figure. So if I did that right here, trying to see if I can get all this. So if I use 90%, it's right down here, right where my finger's pointing. If I use 90% on the 47.2 kilowatt hours divided by 0.9, I come up with 52.44 kilowatt hours. However, when I charged the car, in this instance, it reported that it used 47.2 kilowatt hours, but it took 53.18 kilowatt hours to charge the car. So that turns out that I had an 88.7% charging efficiency for that particular charging cycle. If I use that 90% figure I just spoke of, it came out just a little bit lower. It came in at 52.44 kilowatt hours. But your charging efficiency on your car is going to vary around 90% if you're using 240 volts. I've seen it lower than 88%, and I've also seen it up to 95%. So there's quite a few factors which are really hard to track on why that is. But if you can get the actual amount of electricity it took to recharge your battery, then you can get more accurate on your calculating your mpgs. So you have these two numbers. What's next? Well, you want to know your charging efficiency, which just means you divide those two numbers by each other. 47.2 over 53.18 equals 88.7%. So now the calculations. I take the 53.18 and I multiply it times 1,000, and that gives me 53,180 watt hours for 216 miles. Over 216 miles, that figure yields 246.2 watt hours per mile. This is this top calculation right here. Okay. Now, we're still not there yet. We need to know the miles per kilowatt hour for calculating mpg-e. So, basically what I do is I divide 246 watt hours per mile into 1,000 watts, which is a kilowatt. So 1,000 watt hours divided by 246.2 watt hours tells me that I'm averaging 4.0617 miles per kilowatt hour. And here's this calculation right there, right where my fingers are. Okay. Now, once we have that figure, we know that there are 33.7 kilowatt hours in a gallon of gas equivalent of energy. And that's according to the EPA. So that's what I'm using. I don't think it's correct. And the reason I don't think it's correct is because they're considering regular unleaded, and they're not considering the fact that majority of the country has ethanol in their gas, which reduces the energy content down to 32.77. So at any rate, using the EPA figure, so we can all agree on a standard, we just multiply the miles per kilowatt hour times 33.7, and right here is the math, and I end up with 136.8 mpg-e. See my fingers right there on either side of it. It's highlighted. So now, just got a few notes here. Please note that the miles per kilowatt hour calculation is more accurate than your dash readout. Your dash readout, where your speedometer is on the Chevy Bolt, typically only goes to one digit. It might say you've got 4.1 miles per kilowatt hour. And it's also part of the guessometer system. So as you can see, I came up with 4.0617, which is far more accurate figure. And of course, it's an accurate figure for the whole cycle that I ran, not just part of it. Not an instantaneous readout, for example. So if I'd have used the 90% figure instead, I would have ended up with 138.8 miles per gallon E. So you can see it would be just a little bit more optimistic. So let's see if I have some notes here. Okay. Right now it's June, late June, early July. So this is kind of the warmest part of the year in southern New Mexico. So I don't tend to charge during the day, even though I have solar power. And the reason for this is the ambient temperatures might cause the car to run cooling cycles on the battery to keep it cool, and I would use more energy to charge the car. So that would lower my mpg right there. So what I do is I wait till sunset. We get rid of the radiant load of the sun being up, and then temperatures begin to cool off. So an hour or so after sunset, I may plug the car in. Now the reason I do this is because it's also set up for priority charging, which will charge the car right away to 40%, and then it'll stop. And the reason I do that is, well, what if I had to go to the emergency room or something? I had a hangnail, and I could go out and jump in my car instead of my pickup truck, and we could get to the emergency room or some other emergency, wherever that might be, whether you needed a bucket of ice cream from the local store or whatever. So then the car is set up on departure charging also. So it's set up for, let's say, 7 a.m., which by that time the sun's rising again. So during the night, it'll finish the charge. And so that's my methodology for charging the car. Now in the winter, I'll charge it in the daytime because I want it warmer when it's charging, not colder. And also, I'd like to go ahead and avail myself of the solar energy I am producing with my solar panels. Now, my solar panels in my car, for my house, it's only a 5.1 kilowatts system. And the car takes 7.2 kilowatts. So, as you can see, even if I'm fully producing, let's say I'm producing 4 kilowatts, I'm only producing about 4/7 of the power I need to charge the car. So, it's not strictly solar, but I do like to do that in the winter. So I don't always charge in the middle of the night. Now, if I was on a demand meter, I would. I'd always charge on off-peak power, of course. So that's it. This is I started a new log for the car when I got the new battery pack. And this is a summation of it right here. And here's a graph. Now this summation is of these I think it's 9 charging sessions. I'll just give you some of the particulars. My lifetime fuel economy for the car is 128 miles per gallon E. My 90-day fuel economy is 128 miles per gallon E. My my three tank fuel economy is 135, so I'm had some higher figures recently. I've had a total of 9 fills, as it says. My average cost for fill up on my car is $6.07, 3 cents per mile. Total fuel used is 13.5 equivalent gallons for 1,728.8 miles. So my total cost is $54.59 for 1,728 miles. So my average tank distance is 192. And I try to keep, I try to charge up from, let's say, 10 or 20% all the way back up to 90%, and then I try to go 2 or 3 days before I charge up again. And I don't subscribe to this always be charging thing, which is fine metric if you have a granny charger, because you're going to need to always be charging. But if you have a level 2 charger, 240 volt outlet in your garage, you don't need to do that. Just treat it like a car. Fill it up, in this case to 90%, and then drive it down to below a quarter battery tank. So there you have it. That's my summation about how to calculate mpg-e, the reasons to do it, and the reasons to try to achieve some kind of accuracy when you are doing it. So use a number off the pump or the EVSE equipment. And if you don't have that, you can use 90%, which will get you close. So, happy electrified vehicle traveling, folks. Take care, everybody. See you on down the road. Bye-bye.